This is Higher Maths, it's practice paper E, and we're looking at question 1 in the calculator paper. Okay, a line L1 passes through the points A and B. The line makes an angle of A degrees with the positive direction of the x-axis, so that's from here round to there. Find the value of A. Right, so the way that we're going to approach this one is if we work out the gradient of the line between the 2 points there, then what we can do is we can use the tan theta equals m formula to work out the value of the angle. Let's go ahead and do that. Right, first thing we're going to do is we're going to find the gradient of L1, the line. Okay, and it's just y2 minus y1 all over x2 minus x1. Okay, that's going to be equal to, let's go with 4 take away 0, and 5 take away minus 3. That'll give me 4 over 8, and simplified down will give me a half. So what I then said was we can do to find the angle is use the tan theta equals the gradient. Okay, so what I'll do is I'll replace the theta with the A, and we're going to work in degrees, and that's going to be equal to the gradient of a half. So A is going to be equal to the inverse tan of a half, and on the calculator that should give us 26.565 degrees, or 26.6 degrees to 1 decimal place. Okay, so this is not the same as the answer that you've got in the solutions. I think the solution says 45 degrees, but it's 26.6 degrees to 1 decimal place. Okay, let's move on and we'll look at part B. Right, so a second line, L2, so that'll be this line that's here, with the equation 4x plus 3y equals 12 crosses the line in A. So there we go. The angle between the two lines is B, so that'll be that one there, and what we have to do is we have to find the value of B. So let's start off. What we'll do is we'll get this equation around into the form of y equals mx plus c. Once we've done that, we can pick the gradient straight from that, as long as we've got y equals from there. Right, so what we're going to do first of all is find the gradient of the line 2, okay? So let's go for starting with the equation that we're given. So it's 4x plus 3y equals 12. So let's flip over the 4x. That'll just give me minus 4x plus 12, and then divide throughout by 3. So it'll be minus 4 over 3x plus, and that'll be 4. Right, so we know that that's in the form of y equals mx plus c. And all I'm interested in there is this part here, that's taking the gradient out. So what I can say here is that the gradient of L2 is going to be equal to minus 4 over 3. Okay, once I've got the gradient, what I can do is just the same as I did over here, I can work out the angle. And the angle that I'm going to work out is going to be the angle from the horizontal, from the OX axis, and the angle that I'm going to work out here first of all is going to be that angle there. I'm going to just call that one theta. Okay? Right, let's go ahead and work that one out. So what I've got is I've got tan theta is going to be equal to the gradient, and it's a line 2 that we're looking at. So keeping it at theta, and that's going to be minus 4 over 3. Now if I think about the cast table, I'll sine tan cos, then what I'm looking for is I'm looking for an angle that's minus when it's tan, so that should give me an answer in there and in there. But this time I'm only really interested in one angle, and it's the angle that's going to be this side here. So I'm only interested in the one that's from there round to there, from the positive direction, okay, from the OX axis. Right, so I'm going to find the one in the second quadrant, so let's find the acute angle first. And then what we'll do is we'll find the angle in the second quadrant. So what I've got is I've got theta is going to be equal to the inverse tan. I'm dropping the minus because I'm going to be finding out the value once I've done that. So that should give me 53.1 degrees. Okay, so that's giving me that angle there, 53.1. So I'm going to find out the next angle, which should be the angle, let's see, right, so let's work that one out because it is an obtuse angle. So what we'll go for is theta is going to be in the second quadrant. Second quadrant, we're going to have theta being equal to 180 degrees minus that 53.1, which should give me 126.9 degrees. Okay, so that's the answer to this one here. So that one there equals 126.9 degrees. Now what I'll do is I'll find out this angle in here. I'm going to call that C. Okay, so angle C is going to be equal to, remember what we've got is we've just got a straight line that's sitting here. So if I look at the properties of a straight line, 180 minus 126.9, and that should really just take me back to that angle that's there. So I know that C is going to be equal to 53.1. Therefore, what we'll do is angle B is going to be equal to 180 minus, and we've got 26.6 from part A, and what we've got is 53.1, and all we're doing is using the properties of the angles in the triangle, adding up to 180, and from there what I should get is my final answer, that will be 100.3 degrees, and that will be the question complete. Right, first mark here we're going to get is for getting the gradient. So this gradient here, we'll then get a mark for, I'll go for that there, substituting in, and 1 mark for getting the angle. So that's the 3 marks for part A. For part B, let's go for the gradient, getting the gradient first of all. So that will be that gradient there. We'll then get a mark for setting this up here, and I'll get a mark for this angle there, the 126.9. Then finally, I'm going to get 1 more mark for the final answer, which is 100.3 degrees. So this question here, out of a total of 7 marks.